In this project, we will learn how to interface with a Wii Nunchuk using the Arduino. The Nunchuk is an inexpensive component and packs a lot of functionality with an accelerometer, joystick, and buttons all housed in one assembly. It can be used to control many aspects of your electronics projects. We will see how the Arduino Nunchuk adapter can be used to interface with the Nunchuk and will incorporate a handy third-party library to communicate with our Nunchuk. We will eventually use the Nunchuk to control our pan tilt assembly. Let's take a look at the objectives. By successfully completing this project, we will have mastered the following items. You will understand how to connect the Wii Nunchuk to the Arduino using an Arduino Nunchuk adapter. You will also understand how to take measurements from the Nunchuk using the Arduino Nunchuk library. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, a Wii Nunchuk, the Arduino Nunchuk adapter, and connecting wires. Let's first address how the Nunchuk works. The Wii Nunchuk accessory bus actually has a 6-pin data connector. However, only 4 of those pins are actually useful to us. Using the handy Nunchuk adapter, we can plug this into our Wii Nunchuk and connect the other pins to our Arduino. There are 4 pins that are exposed to us. The negative pin is connected to ground, the positive pin is connected to 3.3 volts, and the clock and data pins can be connected to any Arduino pins. We will be using pin A5 for our clock and A4 for our data. By using the Arduino Nunchuk third-party library, we will be able to communicate with our Nunchuk in code. We can determine the position of the joystick and gauge accelerometer measurements. We can also determine if buttons are pressed. We will see some of this in action in more detail when we examine the code. Let's take a look at our circuit diagram. Once the Arduino Nunchuk adapter is connected to our Wii Nunchuk, the wiring is very straightforward. From the ground pin on the Arduino, we connect to the ground pin on the adapter. The power pin on the adapter is connected to the 3.3 volts pin on the Arduino. The data pin on the adapter is connected to pin A4 on the Arduino, and the clock pin on the adapter is connected to pin A5 on the Arduino. That is it. That completes our wiring. Let's go ahead and wire up our Wii Nunchuk. So this is the Wii Nunchuk adapter. As you can see, it's very tiny. This end is where we plug into the Nunchuk, and it has 4 pins. So there is a clock pin, a data pin, and the positive pin goes to the 3.3 volts pin on the Arduino, and the negative pin goes to ground. So very tiny. Here is the Wii Nunchuk, and all we need to do is take our Nunchuk adapter, and we're going to connect it, as you can see, in the actual Wii Nunchuk external accessory, and now that's in there securely. So once that's in, that's the connection that we need to make, and now we can plug this into our breadboard. So I'll go ahead and plug that into the breadboard. So our first connection is ground. We're going to connect ground from the Arduino to the ground pin on the Nunchuk. Next, the 3.3 volts pin on the Arduino. So just remember that that's the pin above the 5 volt pin on the Arduino. We're going to connect that to the positive pin on the adapter. Next, the serial data pin, we'll connect that to pin A4 on the Arduino. And the final connection is the clock pin. We will connect that to the pin A5 on the Arduino. Okay, that completes our wiring. Now we're going to go ahead and upload the code to test out our Wii Nunchuk to see that we can take the readings. One thing you'll want to remember is that we have to include that Arduino Nunchuk third-party library. I'll go through that when we delve into the code, but if you're trying this initially, remember you'll have to install that library and restart your Arduino. I have actually taken the sample program, the Arduino Nunchuk demo, from Gabriel Bianconi, hope I pronounced his name correctly. He wrote this library, and I modified it slightly to add in some more comments with regards to the X, Y, and Z positions and so forth. So it's the same sample program, but I modified it to add in some more comments to make it a little clearer when we're looking at it. So I'll go ahead and upload the code. And while that is uploading, I'm going to open up the serial monitor. Okay. All right, so it's finally completed. So what I'm displaying is the X and Y coordinates of the joystick, as well as the X, Y, and Z accelerometer axes, and the status of the Z button and the C button. So here is the nunchuck. I'm going to demonstrate to you. So I'm going to hold it in my hand. And I'm going to move the joystick, and if you notice, look at the X. If I move the joystick to the left, the X changes to 25. Now it's at the center, it's about 122. If I put it to the right, X changes to 212. Similarly, if you look at Y, I'm going to push the joystick up right now, and the Y goes to 220 or so, 221. It's back in the middle, it's about 134. And if I put the joystick down, you'll see Y goes to 39 or 40. As you can see, by moving X and Y, I'm able to determine the position of the joystick by those readings. So I can equate that to the motion. If I move the joystick, I can calculate exactly where the joystick is and translate that into the motion or the movement of an external peripheral connected to my Arduino. If you look at the accelerometer, if I tilt the nunchuck to the left, you'll notice, look at that accelerometer X motion. It's about 300 now. When I tilt it again, you notice it increases to 600 and close to 700. Similarly, Y, I'm going to tilt it up and down. So you'll notice the Y is at 570. If I tilt it up, you notice that value changes, it decreases to 3 something. And if I tilt it more down, that accelerometer Y increases to 650 or so. And for Z, if I tilt like this, you see the Z value goes to 450, 450s and the 450s. And if I tilt it the other way, it increases to 500s. All right, so in that way, you're able to measure the accelerometer motions on all 3 axes. Now let's look at the buttons on top. You'll notice there's a C button and a Z button. If I press the C button, okay, you can see in the code it's detecting that that's a 1. So I'm pressing it again. And similarly for the Z button, I'm going to press that Z button. Notice it's detecting that 1 and a 0 when it's not pressed, and a 1 when it's pressed. So what this illustrates is using that Arduino Nunchuk library, we can determine the state of the nunchuck, the accelerometer position, the joystick position, and whether buttons are pressed or not. So really handy library, and this is what we'll be using to be able to control our Wii Nunchuk. Let's delve into the code for our Arduino Nunchuk demo. So initially we have to install the Arduino Nunchuk library. So let me quickly show you some details about that. Here is the link to the library. Of course, I will include this in the project resources. But again, what you'll want to do here is you'd want to download, click on clone or download the zip file. All right, you can, I'm going to save that to my desktop. All right, when it's completed, you'll want to unzip it. And of course, rename the main folder. You can take off the dash master. So you'll want to copy this into the libraries subfolder of your sketchbook location. All right, so I'll go ahead and do that to show you. My sketchbook location is in my Arduino libraries, and here it is. So as you'll see, I already have the library in here, but of course that's where you'll put it. That's the same process that you normally use to install any third-party libraries, and then you would restart your Arduino IDE. Okay, let's get back to the code. So at the beginning, we include the wire library and the Arduino Nunchuk library. Then we define the baud rate. The baud rate used in the sample program is a little higher than the baud rate we have been using. So that's what you just want to be mindful of that when you're taking the measurements. You want to make sure that you select this 19,200 baud, because sometimes you might see weird special characters showing up if the correct baud rate isn't selected. Right, so as an example, if you had it set to 9600, which sometimes we do for our, that's the standard rate, you'll see these special characters, but you'll want to make sure that this is selected. You select 19,200 for this program, and you'll see the correct value showing up. So that's just a quick tip there when you are setting up and running the program. So the first thing we do is we create a Nunchuk object, which is an instance of Arduino Nunchuk. So we create that object, calling the constructor, and of course, this was obtained from the Arduino Nunchuk library. We're able to do that because we included that library. Our setup, we do a serial begin, we specify the baud rate, and we initialize the Nunchuk object. So we do a nunchuk.init, and that will set up our object. In our loop function, we simply call nunchuk.update, and that continuously takes measurements of the nunchuk, the buttons, the joystick, and the accelerometer, and we simply go through and print those values out. So for the X position on the joystick, we do nunchuk.analogX, we do a serial print that value. For the Y position is nunchuk.analogY. For accelerometer values, for the X, we do a nunchuk.accelX, accelY, and accelZ. Right? And that will give us the accelerometer measurements. To determine if the Z button is pressed, we do a nunchuk.Z button, and that will give us a 1 if it's pressed or a 0 if it isn't. And then for the C button, a nunchuk.C button would give us a 1 if the C button is pressed and a 0 if it's not pressed. So the library makes it really easy to take readings from the nunchuk in conjunction with the adapter that we connected to the nunchuk, and now you have a really powerful input mechanism that you can use to control your projects. To summarize, in this project you learned how we can interface a Wii Nunchuk with our Arduino using the nunchuk adapter. We were able to take readings from the nunchuk and determine the position of the joystick, accelerometer motions, and determine if the buttons were pressed. I'm sure you can see how handy a component this is to include in your electronics projects. You now have all the knowledge on how to use it, and will be able to greatly enhance the way you control external peripherals. Let's move on to the next lesson, where we address servos for our pan tilt assembly.